All right, guys, are there questions on the assignments thus far? If there are no questions on the assignments, anything that we've done so far, we're going to go on and start 7.5. 7.5 is the last section in Chapter 7 that we're going to be covering. We have a test next week because we're going to look at these first type of solving rational equations, and then tomorrow and Wednesday we will look at another group because I've grouped them into two main sections. These here are a little bit more simpler, and then we'll look at a little bit more harder ones tomorrow and Wednesday. Now the first ones we're looking at are these here, to where we're given two rational expressions on either side of an equation. So we have 3 over x plus 1 is equal to 9 over 4x plus 5. And we want to solve for the value of x. Now, one of the big things here that we still need to be aware of are our extraneous solutions, because we still need to be aware of them. And our extraneous solutions are going to be any value of x that we will get as a solution to the equation, but will not work if we plug it back in. And the main areas that are going to give us that are the denominators. So if the value of x makes either one of these denominators 0, and we get it as a solution, it means it's an extraneous solution. It will not work. So if we look for the extraneous solutions here, or what they would be, our restrictions, well, one of them is dealing with our x plus 1, because this here cannot be 0. So any value of x that makes it 0 will not work for this equation. Well, one way we can find it is setting x plus 1 equal to 0 and solving for the value of x. Well, we would subtract 1, telling us x is equal to -1. So one of our restrictions is that x cannot be -1. So if we get -1 as a solution, it would not be correct because it would make one of the denominators 0. Now the other case is that we cannot have 4x plus 5 be 0 either. We can't have any of the denominators be 0. Well, here the first thing we can do is subtract 5 from both sides, which will tell us that 4x is equal to -5. And at this point here, we can divide both sides by 4, telling us this here that x is equal to -5 fourths. So if x is equal to -1 or x is equal to -5 fourths, those solutions would not be true because it would give us a denominator of 0. So those would be our extraneous solutions. Now it seems a little bit tedious probably to be typing these in and trying to find those at this point. But the nice thing is that if we do those at the beginning, when we go about solving and getting the answers, because once we finish solving, we get the values of x. If one of those values shows up as one of those two answers, we automatically know it doesn't work. So we don't have to plug it back in to check to see, do both sides give us the same thing? It's an easy way to eliminate some of the incorrect answers. Any questions on this here before we get started? Now, for this here, we need to solve for the value of x. Does anybody have an idea of what we can do first? Well, looking at this here, where are all the x values, or the variables? The bottom, yes? It'd be nice if we can get them out of the denominator into the numerator. We don't have any fractions. Well, looking at 9 over 4x plus 5, what can I multiply this by to remove the denominator? Yeah. Because when we multiply by a whole number, a number without a denominator, it automatically multiplies with the numerator. So on this side, we would have 9 times 4x plus 5 over our 4x plus 5. They would cancel. What would we need to do with the 3 over x plus 1? We could multiply it by x plus 1. But what we do to one side, we have to do to the other. So we actually end up multiplying both sides by 4x plus 5 and x plus 1. Now, for this first time, I'm going to write this out. But after this one here, we can go on and cancel in the first step. Because when we multiply this out, for the one on the left, we would have 3 times x plus 1 times 4x plus 5 over x plus 1. On the one on the right, we're going to have 9 times 4x plus 5 times x plus 1 over 4x plus 5. Well, at this point here, well, the x plus 1 and x plus 1, they cancel out. On the other side, the 4x plus 5 and 4x plus 5 will simplify out, leaving us with 3 times 4x plus 5 is equal to 9 times x plus 1. Now, we could have done cross multiplication to get here, the butterfly multiplication, doing this kind of way here. I don't like using that type of terminology with it because it only works if we're talking about proportions of 2 fractions in this setup here with a, so it's not multiplying, it's just solving 2 fractions that are equal to each other. And we can't have anything else on either side. But really, it is the exact same, cross multiplying. Really what we're doing is multiplying both sides by the least common denominator. What will multiply through the entire equation and get the denominators to cancel out. That's really all it is, which we just did here. Now, do we have any fractions left? Well, no. Now we just need to solve for the value of x. So the first thing we can do is distribute the 3 through. So we can do 3 times 4x is 12x plus 15 is equal to, here we distribute the 9. So we'd have 9x plus 9. Now, we don't have any like terms on either side, so we can get x by itself first. So what would we need to do? Subtract 9x from both sides. 12x minus 9x would give us plus 15 is equal to 9. At this point here, we can subtract 15 from both sides, which tells us that 3x is equal to negative 6. And last but not least, we would divide both sides by 3, telling us x is equal to negative 2. And that's all we have to do for this here. Now, is negative 2 one of our restrictions? No. So, negative 2 will work in our original equation, our original problem. Any questions on this here so far? Now, if we wanted to, we could plug it back into the original problem, negative 2 plus 1, and 9 over 4 times negative 2 plus 5. Well, this here would be 3. Negative 2 plus 1 is negative 1. And 3 divided by negative 1 is negative 3. The denominator. Well, 4 times negative 2 is negative 8. Well, negative 8 plus 5 is, and 9 divided by negative 3 is. Both sides of the equation give us the exact same thing, and we don't have a division of 0, so that is the correct answer. Any questions on this here? We're ready for the next one. So I'm going to write it below it so I have a little bit more room to write on the left and right of the problem. So, well, our first kind of main step is to get the variables out of the denominator, really simplify any fractions that we have. So, what can we do to both sides? By the bottom one, so we have x plus 2 times 3x plus 2. Here we're going to have x plus 2 times 3x plus 2. Now, I will say this now, just like with our complex fractions, if we had an x plus 2 appear in several different spots in the equation, do we need to multiply it more than once if it only appears in each denominator once? Well, no. So if we do have, say, x plus 2, and here it was 2 times, or 2x plus 4, really they would both have an x plus 2. So we do need to keep that in mind, because sometimes it can make the equations a little more complicated. Now looking at this here, well, as we saw in the last one, here the x plus 2 and x plus 2 will cancel out. Here the 3x plus 2 and 3x plus 2 will. So really all we're left with is 2 times 3x plus 2 is equal to 10 times x plus 2. So on the last one, I rewrote it with the multiplication step out just so we can see how that simplification does work. But now that we do kind of see how it works, we don't have to continue to do that. Any questions on this here? Well, now we just need to distribute and solve for the value of x. Well, we didn't find the restrictions, but most likely they're not going to show up. Here, 2 times 3x is going to give us plus 4 is equal to 10 times x is plus 20. Our next step would be 2. Well, I'm going to subtract 4 from both sides. But if you subtracted 10x or subtracted 6x, that's perfectly fine as well. Because we could have subtracted 6x from both sides, or we could have, because here I'm realizing I'm going to get a negative value for x, but that's fine. Because then I would subtract not 6x. I would be subtracting 10x, which would tell us that negative 4x is equal to 16, at which point we can divide by negative 4, which tells us x is equal to negative 4. So if we had subtracted 10x first, or if we subtracted 6x first, we would still get to the same place. Because I think that's what some of y'all wanted to do. Subtract, and that's fine. Because the order in which we do really these two steps, not so much this one, it's going to give us the same thing because I could have subtracted 10x from both sides first. Mhm. Let me see. 10x plus 20. 4 minus 20. It'd be negative 16. Yep. That's it. So that's, but the order in which we do the addition, subtraction, moving to either side really doesn't matter. It's whichever way we want to do it. Now, our restrictions on this here, if we solve for this here, x plus 2, what value of x is going to make it equal 0? Negative 2. And if we looked at 3x plus 2, what's going to make it negative 2/3? Because when we look at this here, well, plus 2, I would need to subtract 2 and then divide by 3. And negative 2 and 2/3 do not match up with our answer of negative 4. So that is the solution. Any questions on this here? Let's look at the next one here. So the next one that we have here is 3 over 5x is equal to 2 over x minus 7. 3 over 5x is equal to 2 over x minus 7. Now, I'm going to make sure that I do the restrictions on this one here first and not last. But if we look at 5x, what is going to make that 0? So 5 times x, yes? What times 5 would give us 0? 0. Because if we don't have really anything added or subtracted, it's just a variable by itself or multiplied just with a number, it's just going to be 0. Because we're really asking what times 5 is 0. Well, that would have to be 0. Now, when we look at x minus 7, what minus 7 would give us 0? Well, 7. So if we get a value of x that is either 0 or 7, we know that solution will not work. Okay. Let's go on and start working this here. So what would we need to do first? Multiply by? And? Exactly. We're going to multiply both sides by 5x and x minus 7. And we're doing this to do what? What is the goal with this? To cancel out the bottom terms, to cancel out these denominators. Because here the 5x and 5x will cancel. Here the x minus 7 and x minus 7 will cancel out, leaving us with 3 times x minus 7 is equal to 2 times 5x. Now, if you do feel comfortable at this point here to actually do that multiplication out instead of rewriting it like we did here, to go on and say 3 times x is 3x. 3 times negative 7 would be minus 21 is equal to 2 times 5x, which is 10x. To be able to go on and say this here, that's fine, as long as you're able to keep track of all of the terms. What do we need to do next? We need to subtract 3x from both sides, because we need the variables all on the same side, which would tell us that 7x. And then what would we need to do next? Divide both sides by 7, telling us x is equal to negative 3. And as we see here, our two restrictions for x was 0 and 7. Negative 3 is neither one of those. So x equals negative 3 is our solution. And again, we could plug this back into the original equation and see, yes, both sides do end up being the exact same thing. Any questions on this here? Got something different? Okay, the next one. Okay. I feel like y'all feel comfortable with these here, yes? I think as most of y'all have wondered on most of the stuff we do, can we use the graphing calculator to be able to solve this? Well, yes. Now, with this here, we're trying to find out what value of x will make them be the same. Now, there's two ways we can go about it. And the main way we'll look at this here is that we can take each equation and type it in. So for the first plot, y1, we can say alpha y equals enter, because we need a fraction. The numerator for the first one we can say is negative 4 over x plus 3. Enter. Now we can do the next one. In the second equation, alpha y equals enter, and have 5 over x minus 3. And again, we're looking for where these two have the same value. So we're looking for what value of x, what value do we plug into this function that will give us the same value, the output. And we can graph it. So when we graph this here, we're looking to where they intersect, where these two graphs cross. Because if we find that point, we will be able to tell where they are the same. And as we look at this here, we do see one point of intersection clearly in the middle, yes? Now, will either one of these ever equal 0? No. The only way for them to be 0 is if the numerator becomes 0. Well, both of these have numbers for numerators, so there's no way that they can actually cross the x-axis. So that means to the left and right, if we extend it out, they're never going to cross, because the red line, or the red graph over here on this side is never going to cross the blue. They can't cross it, so the only point of intersection is right here in the middle. So let's look at the table to see if it gives it to us. Second table. So we're looking somewhere close. So we got an error at -3 for one of them. But in +3, we'll have an error also. But looking at this here before we hit 0, because that's where it crossed, do we have a x value where the two y values match up? Well, no. So what that most likely means is that the solution is a fraction or decimal. So at this point here, we could go into actually solving it the way we have. Now the calculator will do intersections. If we go second trace, our calculate, because the few things that it can calculate, one of them is value. So if we put a value in, it'll tell us what the y value is for a given x. The second is zeros, so where it crosses the x-axis. The third one is a minimum. The fourth one is a maximum, highest or lowest point between kind of a range that we set. The fifth one is intersection, and that's the one we'd want. So the last two are derivatives and integrals. So if we go down to number 5 and hit enter, it's going to ask for intersection. And when we look at intersection, we don't want to use the up and down arrows. We want to use the left and right. And what we want to do is put that cursor as close to the intersection that we want as possible. And here it already kind of gave us one really close to it, and most of the time it will. And we say enter, essentially saying that for this one graph, the intersection is somewhere close to this point. Now it asks for the second graph, where is the intersection close to? Well, most of the time it does put it close to where it needs to be. We can go on and hit enter again. Now, always, after we tell it where the first 2 points are kind of probably going to be, it asks if we want to guess. If we want to guess what the value is. Well, no. I don't want to guess what that value is. And here it tells us that the intersection is negative 0.3 repeated, and the y value is negative 3/2. Well, what do we know about 0.3 repeated? What is it as a fraction? 1/3. So it's telling us that the solution for this is negative 1/3, and if we plugged it into the function, both of those would equal negative 3/2. So when the x value is negative 1/3, it will make both sides the exact same, and the value that they are the exact same is at negative 3/2. Now, if the solutions aren't these nice decimal numbers or nice whole numbers, it's going to be a little difficult doing these on the graphing calculator. Now, if we look at this here and did this by hand, well, the first thing we would have done is multiply both sides by x plus 3 and x minus 3. And when we multiply both sides by the x plus 3 and x minus 3, on the one side, the x plus 3 and the x plus 3 would cancel. The other, we would have the x minus 3 and x minus 3 canceling. What that would leave us with is negative 4 times x minus 3 is equal to 5 times x plus 3. Now again, at this point, we can distribute the negative 4 and distribute the 5, which would give us negative 4x plus 12 is equal to 5x plus 15. At this point here, we do need to get the value of x on the same side, so we can add x to both sides. Why do I feel like I typed the wrong thing in? 9x plus 15. No, we're good. Then we would subtract 15 from both sides, which would tell us that negative 3 is equal to 9x. And last but not least, we would divide by 9. And 9x divided by 9 would give us x is equal to negative 1. And that there would be our solution. Now in the graphing calculator, it did give us 2 y values that were undefined, and that is our restriction. So it's really telling us that x cannot equal negative 3 or 3, because that's where it is an undefined function, because it's a value that causes the denominator to be 0. We also call these graphically vertical asymptotes. They're vertical asymptotes. They're lines that where the denominator of the equation or expression is 0 if we went and graph them. Any other questions on this here? I think we feel comfortable with these here. Yes? So let's look at these next. Now, as we can see here, solve rational equations using the least common denominator. So they've removed the cross multiplication, and the reason we can't do that is because, well, there's not just 2 fractions, we have 3. Now we could get it to 2 fractions by actually going through the addition process to make these 2 here into 1 so that we can do the cross multiplication, but there's no point to that because we could use the least common denominator, what we were just doing, to actually solve these anyways. And the least common denominator is a set of terms or term that we can multiply every fraction by to get the denominators to simplify out. Well, looking at the negative 9 over x, what would we need to multiply it by to get the denominator to simplify? What do we think? Well, x, because the 9 over x would be x, yes? So we have to multiply everything by x. Will that simplify all the denominators? No, because we have 1 left. We need a 4. So if we multiply all these by 4x, we would get those denominators to simplify. And if we do this multiplication here, I'm going to write it out for the first one. So in our first one, we're going to have 5 times 4x over x plus 7 times 4x over 4 is equal to negative 9 times 4x over x. When we look at these here, well, the x divided by x will cancel. Here, the x divided by x will cancel. And in the middle, the 4 and 4 will cancel. Now let's see what that leaves us with. So the first rational expression, we're left with 5 times 4 in the numerator, which is plus 7x is equal to almost negative 36, because the x's would have canceled. And that's it. After we do that multiplication of 4x, all the denominators are gone, and we're left with 20 plus 7x is equal to negative 36. Well, now we need to get x by its, so we can do that by subtracting 20 from both sides. And this here will tell us that 7x is equal to negative 56. And lastly, we would divide by 7, which tells us x is negative 8. And that's it. Now at this point here, we could plug this back in to see if this does prove true that this solution is correct, and it would, because our only restriction, which I, again, didn't point out, x cannot be what? Because if we look at here, at the beginning, we can only find the spots where the denominator would become 0. Now the 4, since it doesn't have a variable with it, we don't have to do anything with that part. So the only two we're looking at is our x and x. Since they're by themselves, they don't have addition or subtraction with it, it's just going to be 0. And well, negative 8 is definitely not 0, so that is our solution. Any questions on this here? Let's look at one more of these, because I feel like y'all have got the hang of these. These aren't that bad. Would y'all agree? So this one here is going to be a little bit more tricky, just a bit, not by a whole lot, to solve. So the first thing we need to do is to remove all the fractions if we can. So what do we need to multiply everything by so that the fractions simplify? X and x minus 5. X times x minus 5. X times x minus 5. And I'll normally write these onto the equation, especially if they're already provided. Because if I don't have to rewrite it out, I'm not going to rewrite it out. And if we look at this here, well, the x minus 5 and x minus 5 will cancel out. Here, the x and x will cancel, which will leave us with 1 times x minus 5, which should be x times 5, minus 8 times x is equal to 3 times x minus 5. Any questions on this so far? So let's go on and start distributing so we get rid of these parentheses. X times x is, x times negative 5 is negative minus 8x is equal to 3 times x is minus 15. Well, this one here is different than the previous because we actually have an x to the power of 2. So this is a quadratic. And anytime we get a degree for x, an exponent with our variable greater than 1, we need this thing equal to 0. So we can combine like terms first. So negative 5 minus 8x would be negative is equal to 3x minus 15. So we need to get everything on the same side of the equal sign. So the first thing we can do is minus 3x from both sides. And we minus 3x from both sides. We get that x squared minus 16x is equal to negative 15. Then we would add 15 to both sides, which is equal to 0. Any questions on how we got to this point here? Now looking at this here, there's a good chance we can factor it because the number in front of x squared is 1. And can we get factors of 15 that add together to be 16? 1 and 15, 1 plus 15 is. So this here will factor. Now since the 15 is positive, the signs are the same and they match the sign of the middle term, which would be negative and negative. The factors of x squared are x, and the factors of 15 are 1 and 15. And those would be the correct factors. Now, here, because we did factor it, yes? And I have two things multiplied together, they give me what? 0. Well, if two things multiply together to give me 0, it means that one of these has to be 0. That's the only way that we can multiply two things together to get 0 is that one of them has to be 0. So either x minus 1 is 0 or x minus 15 is 0, and that's our 0 product property. So we'll split them up, set them equal to 0, and then finish solving. So x minus 1 is equal to 0. Well, the first thing we'll do is add 1, telling us x is equal to 1. And that's it. So one of the values for x is x minus 15 equals 0. Well, here we can add 15 to both sides, telling us x is equal to 1. And we get these two here. Now we do need to check and make sure that we didn't have a restriction for one of our values. And the two denominators in this case were x and x minus 5. Well, the restriction for this one would be x cannot equal, and for this one here, x cannot equal, but did we have 0 or 5 as one of our solutions? No. So the solutions for this here are 1 and 15. What would happen if all the solutions that we got were our restrictions? Then it would be no solution. Because if all the solutions match up to our restrictions, then it is no solution. There's not a solution for that problem. Any questions on this here? Any questions on anything we did so far today? We feel good with this here? As we have two more, but those really aren't any different than what we've already done. And that's it for today.